So here we go for the starters for chapter 7.4. This is the first one. I'm going to do 3 separate recordings because that seems to work better. So here we go. We've got an inclined plane, which is rough, and it's inclined at 35 degrees to the horizontal, and it's got a weight of 22g, or a mass of 22 kilograms, so a weight of 22g acting downwards. And there is a tension in a string stopping it sliding down the slope. Mu is equal to 1/8. There's the tension. It's on the point of slipping down the plane, on point of slipping down the plane. Find T. So pause it there, put the forces on the diagram, have a go at the answer, and then check it with the rest of the clip. So I'm carrying on now. So here we go. So the other forces, we've got a normal reaction R, and because it's on the point of slipping down the plane, the friction must be acting up the plane. So we do our standard things, resolve parallel to the plane, and we get T plus the friction, and then the component of the weight acting down the plane, and that's going to be opposite the angle, so that's going to be 22g sine of 35. And while we're looking at that bit, we've also got the bit next perpendicular to the plane, and that's next to the angle, so that's going to be 22g cos 35. And let's just put the angle in while we're at it. So that angle there is 35 degrees. Okay, so T plus the friction minus 22g sine of 35 is equal to 0. So friction is equal to 22g sine 35. And we're asked to find T, minus T. And then what else have we got? Resolve perpendicular to the plane, R minus 22g cos of 35 is equal to 0. So they're the perpendicular ones, and this is coming from the ones parallel to the plane. Okay, so R is equal to 22g cos of 35. Friction on point of slipping. Friction is equal to mu R. So now we can substitute in from above. We're given in the question mu, which is 1/8. R is 22g cos of 35, and we can substitute into the friction 22g sine of 35 minus T. So now we've got one equation with one unknown. Add the T across, subtract the 1/8 22g cos 35, and we get T is equal to 22g sine of 35 minus 1/8 of 22g cos 35, and tap it in the calculator. Sine 35, well, it won't be that far from sine 30, which is half, so it's 11g minus a bit around 100. I would think, let's tap it in the calculator, 102 newtons. Okay, there we go. That's the first one.